So, who might be willing to share their partner's card at this point? We'll take two brave individuals. Who might be willing to share their partner's card? Thank you. We'll go Scott 1. Who else might be willing to share their partner's card? There was lots of pausing and paraphrasing going on. I heard it. Thank you, Molly. Scott?
The person I was Kelli Litter. She chose this Stringin along because last year she was in a group with Marcus and they started a little discussion in problem strings, and so she just wants to know a little bit more about it, and so that's why she's here.
We did have an opportunity to plant seeds of this opening routine last year, so we had an opportunity to dabble as a math team. And we thought because of the interest that was generated from that, we'd do a breakout this year. So thank you. And Molly?
My partner was Josh. He's right over here, the fourth grade teacher, and he really enjoys doing number talks in his classroom. So he just wanted to discover more about number strings and take on something new to do with his students. His takeaway from this morning was that he really enjoyed the discussion around the difference between professional development and professional learning and what those really mean for us as teachers.
Josh is continuing to build add his tools to his tool belt. So number talks is something that's comfortable. How can we extend that and experience something maybe a little bit different? So thank you. So the agenda is posted visually, but you'll also notice it's strategically positioned right behind Kelli. This will be our journey for our conversation today. First, we're going to explore the ideal classroom in just a moment. Formative assessment for where are we at in our understanding of problem strings. The why and the what, so we might need to create some context around these things as well. We'll actually do one. We'll have the opportunity to do one today so you can experience it. And then lastly, how are we taking this information back to our students? So you can find it here temporarily, or the agenda is posted on Kelli. So how we're going to engage in this process is first, it's important for us to know our why. And knowing that we didn't have enough time to process this morning around the framework, there seemed like a very strong interest in exploring that further. We're calling an audible based on the group's needs. And if you could reflect around the buckets of where that teaching framework for mathematics, how it aligns with your vision of the ideal classroom. So as you think about what is your ideal classroom, this will cause you to reflect internally on what do I value about students? What do I value students doing? And you'll notice the structure on the second picture on the left. It's simply a table for us to explore thinking. So on the left, what do you see in your ideal classroom? What does that look like? What will students be doing? What will you be doing? Who is in the room? The middle column is what are you hearing? What are you hearing from yourself? What words are coming out of your mouth? What are you hearing from students? What does that classroom space feel like? And then lastly, what does it feel like? It's not as tangible, but what is the feeling in the room? What we call the big E for environment. So it may help you to immerse yourself into what that ideal space might feel like and allow yourself to explore what am I seeing, what am I hearing, and what does it feel like for me in this space. Okay. We'll take an opportunity to just live in this space for a moment. Okay? It's all right, Kelli. It's good.
It's okay.
So for the next 2 minutes or so, immerse yourself in your ideal classroom experiences and reflect upon what you're hearing, seeing, and feeling. Right, if you could pause and get your last idea recorded, please, and then direct your attention up front. Thank you. Kelli, can you remind us why we might be doing this?
Yeah, just like as in our classrooms, we want to make sure that all of our tasks and activities and conversations tie back to our learning intentions and success criteria. This activity is going to tie directly back to identifying who we are as teachers and what we want our ideal classroom to look like and what problem strings are, and make sure that we're continuing that journey to merge those two things together. So what we are and what we want our classrooms to look like, what problem strings are and how we can form one verb together with those.
Sounds like we'll have an opportunity to use this information later as we view number talks through this lens. So in order to create a more common understanding and diverse perspectives, I wonder if we might be able to form larger groups. So Cedar Springs folks, would you maybe mind joining that group to create a group of 5 or 6, I think, when Dave comes back? Could these two groups maybe merge together? And then if you two wouldn't mind joining those three in the corner there, that should make the numbers a bit more even. So what we're going to do through our conversation, and yeah, go ahead and if you want to move now, that might be easiest. Thank you for being flexible. So you're probably wondering why this mixer is up here. Instead of owning these ideas individually, what we're going to do is push our papers to the center of the table. So everyone please push your papers to the center of the table. Mix them up, kind of like 52 pickup. Okay, mix them up. Everybody randomly pull one out and then turn it over. Randomly pull one out and then put it face down because we don't want to read it yet. You should not have your own. Put it back in the middle. It works out that way. It's a math problem. Okay. What we're going to do in just a second is we are going to familiarize ourselves with the document in front of us. Hopefully it's not yours. Shouldn't be yours. And we are going to share these items. We are going to share all of these items. So we are simply, if you could direct your eyes to the screen, please. We are going to round robin the responses without crosstalk. If a team member says something that you have on your paper, put a check mark next to it. We're going to see how many check marks we have with the content. So we're going to round robin. Let's do the person with the brightest color shirt. We'll start the conversation. We will go clockwise until all the items are exhausted, and we have a full list of what it looks like, sounds like, and feels like with check marks next to those. Then when you're done with your round robin conversation and putting check marks next to the common items, we then ask that you chart commonalities through combinations of words and images on the chart paper on your table. So this will be round robin sharing the information in front of you after you make sense of it. Check marks next to common items that our group has surfaced. And then through words and images, create a representation of the synthesis of your dialogue. What questions might we have about the next 7 minutes? Perfect. Person with the brightest color shirt, please start the conversation. I appreciate, Kelli, keeping me mindful of time. So even though your poster may not be done, if you could place it up around the room. At this time, if we could pause. I think it might be interesting to take 20 seconds and look around the room to see where our community, what those experiences might look like in the ideal classroom. So what does our community say about the ideal classroom? Let's take 20 seconds just to look around the room and familiarize ourselves with our ideal classroom and our current beliefs.
All right, thank you for charting those ideas. We will come back and visit those towards the end. So know that conversation has not been tabled completely. Moving on, part of our purpose today was involving what are problem strings. We want to understand the what. In order to gain an understanding of where we're at as a group, take a minute to think about, have some internal dialogue around what do I know about problem strings. So as you're thinking about what do I know about problem strings, quantify that somehow and rate yourself on a scale from 0 to 10. In a moment, you're going to have a chance to use the scratch and sniff markers that you all wanted to use for your charts. And we are going to place a sticker up here to represent what we know right now about problem strings. So to review, to summarize, you're going to take a minute to think and have some internal dialogue around what do I know right now about problem strings? What are they? What do they look like? Then we're going to quantify that on a scale from 0 to 10. 0 is I'm here for the first time and I don't know what they are. A 10 would be I know a lot. I might have tried them. I could probably explain them. Maybe we should invite you up. And then when I give you the green light, I will have you come up and place your star on the chart. What questions might you have about this? All right, take about 30 seconds. Have some internal dialogue around what are problem strings. Find a yellow star on your stickers and think, where am I? Am I a 0 or a 1? Am I a 10? When you're ready, bring your yellow star up and place it on our number line.
Might I advocate, please identify the number that you want. Hold that number in your head and don't let the group bias you. It's important that we have authentic responses from where you're at. And wherever you're at is perfect.
Thank you. Just as we do with our students, we want to get an idea of where we're at as a group so we know how to tailor our advice here. Also, I appreciate none of you being that student that just puts it in the middle. Thank you. It's very aesthetically pleasing. We will come back and revisit this towards the end.
So it seems that most of us, there's a large portion of us that we really don't know as much as we'd like to know about problem strings. And I appreciate you taking the opportunity to be a part of the conversation here to learn with us today. So in order to help create further context around what problem strings are and what they aren't, we are going to take an opportunity to engage in a reading that actually is phrased what they are and what they aren't to bring further context. Kelli, would you mind handing those out? And I should also mention that the information we're getting from our slides are generated from these texts. So this is the advanced algebra version of problem strings. There is an algebra version as well, geared more towards middle school and obviously algebra. The author of these are Pamela Weber-Harris. She used to work for Texas Tech, I believe, and now she does individual consulting. I've had the opportunity to be part of several of her trainings, but some examples that we use and we will be experiencing today together are within these texts. So the reading is from this text, and some of the examples we'll be engaging in are from these texts. So if you'd like to see one, we'll have one example up here for you. Yeah.
You said that name one more time.
Yep. Pamela Weber-Harris.
I have the other one.
Mm-hmm.
Oh, yep, sorry.
So there's a problem string book that's algebra oriented and then advanced algebra. If you're curious about the elementary versions as well, we can get those for you, but there are no specific texts for elementary. There are examples within number and numeracy at the early level. So we are going to engage in the Say Something protocol. And what this looks like is that everyone could have their finger right on the beginning where it says, what is a problem string? So please point to what is a problem string. That's where we are going to begin reading. With an elbow partner, you're going to identify what portion of text you want to read. So maybe it's just the first paragraph. And so what this would sound like is, I would say, Kelli, let's read to this point on this point in the reading. Then we'll both silently and individually read that portion of text, silently and individually. And I'll patiently wait until Kelli's done, or more likely she'll wait for me. And at that point, say something that stands out to you. So what connections are you making? What's in your mind after reading that paragraph? We'll have a short dialogue, 30 seconds is fine, before identifying the next section of reading and engaging in the same process again. So we're going to identify our partner and what portion of text we are going to read first. Read it silently and simultaneously, and say something about what we read. We're going to repeat that process until we reach the end of the table on the back. Okay. What questions might be living in the room? Perfect.
Plus, how much time?
So let's keep our conversations 20 to 30 seconds for the say something or less. We want to make sure we have enough time for our number talk experience that we're going to go through. So short, say something. Thank you. Happy reading.
All right. You could put your eyes up here. Thank you. So we began to discover the what are problem strings, and know that over the course of the next half an hour or so, we're going to keep doing that. So because of time, to be totally transparent, because of time, we're going to table this for now and move on, but know that things will become more clear as we do move on. So I know that there's some questions in the room, and I'm sorry for not getting to those right now, but we will be answering those as we go.
So I wonder how your reading might connect to what a few problem strings might look like. So right now you may not have a lens of what are these things we're even talking about. We have some context, but we'll have examples here in just a moment, and Kelli will share those with us.
We have a couple of examples here, as Marcus said. This is an example of a problem string intended for 3rd or 4th or 5th grade. We have an objective up top, developing students' abstract understanding of repeated addition. In elementary, similar, I'm trying to run through this fast, but also do it justice. Similar to number talks, we use visuals. We try to get at that concrete representational understanding of math topics, but also we have an end goal in mind. And in this one, our end goal is to be tying these visual structures to a repeated addition concept. And then Marcus, can you talk?
Can we go back one more, Kelli?
Yeah.
I'm wondering what connections, does the back here work? I'm wondering what connections you might make from the reading, what it is and what it isn't. What connections are you making towards the problem string or number talk? Problem string or number string. Number string. I'll present it up here. What connections are you making?
Strings are connected, like they keep building on each other.
So we're noticing a 2x5 array then transfers into a 4x5 array, so students can still have access, then increasing the complexity as the images move forward until we reach an open number line, and then the abstract representation. So strategically sequenced problems is what you're surfacing. What other connections?
Starting out with the visual,
Mm-hmm.
then you're tying numbers to a visual, then you're just going right to the numbers. Is that what you're...
Mm-hmm. You have strategically sequenced problems that are put in front of students. We want to make sure all students have access to the beginning, because if we put something up there that they don't know right off the bat, well, there's no sequence of learning that we can go through. So it's really a balance of knowing where our students are, and then going back a little bit so they have access to the problem, and then having a sequence of continually sophisticated mathematics that will push them into a new space that they haven't yet discovered. So we want them to have access with something that is tangible, but that push them into a new space of understanding.
So what you're saying is, like you would give them that first column, and discuss that first column, and then maybe go into that second row, pictures after that, like with them not seeing that second.
Yeah, thank you for clarifying, Maud. The way that Kelli, maybe you could speak to how you might present this.
I would present one picture at a time, one visual at a time. And I would call it, it's hard to not say number talk, but it's more of an elongated number talk. So many number talks that are intentionally sequenced to get to a learning intention. So one visual at a time that build on each other and build on the concepts that eventually end in this goal that you want students to come to a new understanding about.
Now, would that be over several days, or would that be all in one?
Great question. That would all be in one sitting. So it's not a 10-minute number talk, a 10-minute number talk, a 10-minute number talk. It's a 2-minute chunk of time, a 2-minute chunk of time. So it's elongated number talk. How could you summarize that, Marcus?
Yep. So once again, we want students to have access to that first problem. So we'll just show the 2x5 array, and I'll say, how many are there? Students will say, 10. Awesome. Well, how do you know that? Well, I see 2 and I see 5. So depending on what level, maybe they'll say 2 times 5 or 5 plus 5. We'll say, fantastic. Thank you for your thinking. Then I would project the next one, the 4x5 array. When you're here, what strategies might you be able to continue on from our first picture? So you leave that visual up there as a strategy for students, because our hope is that they take that strategy from our 2x5 and they apply that strategy to a new context. And they're learning new strategies and applying that to a new context and pushing them into that uncomfortable space. We want to leverage the strategies that students are using to push them into a new space.
So what questions do you ask for that last one? Or is that just where you're hoping that they get to?
Well, to pose that question specifically, I might say something like, well, how many are here? This is a different representation that we haven't seen before. What does this come out to be? And if students don't know, they're not comfortable with the numerical representation, then that's our formative assessment and say, you know what, we might be able to revisit this tomorrow to continue building on that.
Are you writing their thinking of the first one, or you're just discussing?
Yeah.
Recording?
With problem strings, models are actually really important in how we're using models as strategies for students. So I'm going to do my best to be very intentional with modeling the strategies that our group comes up with so that you might leverage that modeling in the next problem. Maybe to build off that for a second, it's okay to use materials. It's not, you can write, your students should be writing things, that's okay. They can do turn-in talks. They can use pencil and paper to help them with problem strings.
Marcus, would it be okay for them not to use?
Sure.
So it's your choice as the facilitator whether or not they use materials.
I wrongfully assumed that I couldn't use materials when I was in the training with Pamela. And she came over and gently slapped my hand and said, you know what, you should be using materials. And I was, okay, so lesson learned. So you can use materials, but you don't have to. So as a secondary example of what this might look like, the objective is to develop facility with transformations. So maybe your students have a baseline understanding of what a square root function might look like on a graph. Once again, models. Then I would strategically position, well, what is y equals the negative square root of x? What might that look like? Okay, so it's similar to the first one in this sense, but we're changing it a little bit. And then what would the third one look like? So you can see how we're continuing to complexify the information in front of students. What questions might we have about the secondary example? Or the square root example? I appreciate all you early elementary people hanging in there. As that was put on the board, there were some indicators that that was interesting to us. So those are just a few examples of what problem strings might look like.
We also wanted to provide a few non-examples, as Marcus already slipped up and said number talks, right?
Yeah.
We want to be very aware of how we're talking about problem strings and know that they are entirely different from a number talk. While there are similarities to them, they are an entirely different aspect and function in the classroom. So here are a few non-examples, and we will talk through why exactly they are not qualified as a problem string. So a prompt such as this, a dot image. How many dots do you see? Why might this not be a problem string? The most obvious, it's not a series of questions, right? You're just putting one image up and having a longer talk about one thing. And it's entirely open and constructed by students. When we're doing a number talk like this, we have an end hope in mind, but we don't have an end goal in mind that we are going to get students to or hope that they access before they in a number talk like this, it's wide open. You get, I see 12, right? You get all sorts of examples, and you're charting all of them. We have a splat here. A splat is also not a series of tasks. It is a type of opening routine, and it brings out strategies around one concept. Again, it's open. You have an end hope in mind, but you don't have a goal that you're actually trying to get to and achieve.
So what questions might be living in the room knowing we're trying to create further context around the what? What questions might we have? Yeah?
So a problem string is not a type of opening routine.
A problem string, and that's funny you asked that question because that's always a wondering. It can be identified either way. That's the hard answer.
Because we have like this umbrella image we're trying to explain in our district that all these things are living under. So if I have an umbrella called opening routines, a problem string could be a drop under that.
Absolutely.
And a number talk would be a separate drop because they're not the same.
Yes. And to be transparent, we're still learning and growing in our understanding and uses of problem strings in the classroom. And my original understanding was it was an opening routine, and now that I've explored it more, I see how it could actually be used as a lesson. And we will explore those things more as we go on.
Yeah, I've done both in the classroom as well. If it's something more accessible to students where I just want to spark their thinking, I'll use it as an opening routine. But if I have something that I know students will make connections with, take advantage of that learning opportunity that students present to you. So you can use it as a lesson too. Is there another question? Yeah.
I was just going to make a comment. So if I took this screen and then I added a second one to it that had more splats and more dots, that was more complex than the last one, and I was going at the same strategy that you had with your adding, then I could make this into a string as opposed to just a number talk. So adding one of them that you showed me for a number talk, I could change to a string if I just add more slides to it.
As long as you're very intentional with why you're choosing the next splat, like you said, repeated addition or whatever might come next. As long as you're very intentional with your purpose, then in theory, yes. Intentionality and purpose is at the core of our work. Molly?
So am I hearing you correct when you say, or when I'm understanding that with choosing a point of access intentionally for our student, that should be where we start in designing our number strings, and going from there to build to something that they potentially might not have access to without that provided.
Absolutely. Yeah, great summary. Thank you. Any other questions living in the room? All right.
I like the idea that it can become a lesson in itself, because I can really see how beneficial that would be.
And you'll see that the progression is hopefully quick with those connections. So that's why I hesitated a little bit with your question, is that splats take time to process and unfold. There's a lot of thinking that goes into answering one question to even have access to it. So generally, problem strings are much quicker, accessible. Like, let's knock out the first three because we have access to those, and then maybe getting to some more complex thinking. So we're going to do one in just a moment. So we are going to move forward, given the time. Kelly?
As we prepare ourselves to experience a problem string, I want to orient your thinking around your experience. So turn your eyes to your chart, the ideal classroom. We said we would revisit these. And identify 2 or 3 items from your chart that might align with your routine. So as you're thinking about your ideal classroom, and as we're watching a problem string, how do these 2 things connect? We said that was one of our learning intentions today. Knowing that we have this ideal classroom idea in our head, we have these problem strings. How might they connect? Where do they intersect? Is what I want to orient your thinking to. So again, read back over your charts that you made earlier. Find 2 or 3 things that you could orient your thinking to around problem strings, and think, how do these 2 things connect? How does collaborating connect to problem strings? How does the use of manipulatives connect to problem strings? What questions might you have about that mental task? You could just give a thumbs up when you have your 2 or 3 things. Marcus, knowing what time we have left, would you like
collect that data still? Or should this all be manual?
So essentially, after you identify the 2 items on your board, put that on as a lens. So what will you be looking for specifically through the problem string? How does that relate to your beliefs? We're addressing that first learning intention. What is a problem string, and how does it align with my beliefs? So just put that lens on and be prepared to. You can gather data however you want. If it's up to you and you process best by writing things down, write it down. If you just want to hold it in your head and be a part of the experience more actively, then let's do that. You have the flexibility right now to choose what's best for you as we engage in the problem string. Okay? So we're going to give it a shot. And if everyone wouldn't mind moving towards this side of the room, we will be doing the problem string over on these boards. Feel free to sit down or make yourselves comfortable.
Feel free to pull up chairs. Make yourselves comfortable.
So once again, we're going to be doing this for 2 different purposes. One is to actually experience a number talk as a student. What does it feel like for you? What might it look like in your classroom? And the second lens is, how does this align with my beliefs? What moves might I be able to pull out as a professional educator that I might be able to use in the classroom? So both the learner and student perspective and the professional educator will be holding throughout this process. You'll recognize that the example I was shooting for somewhere in the middle from our K-12 courses. So, thank you class for coming over. We're going to be engaging in a problem string today. And the focus of our problem string is to really become more comfortable with ratio tables. So we're going to ask that you think flexibly and identifying what might be the solutions to this process and engage in dialogue and understanding with your community. So the first question I have for you, we're talking about packs of gum and the number of sticks within each pack. We have packs of gum and number of sticks. So we need an entry point. One pack of gum has 17 sticks in it. My question is, if you can think silently and individually to yourself, how many sticks would be in 2 packs of gum? Show me that you're thinking. Could you think of this? And if you have an answer, just hold up one finger. This tells me that I have an answer and I'm comfortable being called on. If you decide to hold up an index finger and a thumb, that tells me I have an answer, but I'm not comfortable sharing it yet. And you won't be called on at this time. So I have an answer, but I'm not comfortable being called on. So it seems that most of us have an answer in the room. I apologize for not knowing you. Kelly, would you mind sharing how many sticks are in 2 packs of gum?
34 sticks.
34. How did you get that, Kelly?
I took 17 and 17, and I knew that 10 plus 10 was 20. And then 7 plus 7 was 14. And then I took 20 plus 14 to get 34.
Kelly, did I capture your thinking correctly?
Yes, it does.
Thank you, Kelly. What might be another way to solve this? What different strategy might be living in the room? You could raise your hand and identify if you're willing to share a different strategy. For how many sticks are in 2 packs of gum?
So I thought of it of doing 2 times 17. And so I did 2 times 10 gives me 20, and 2 times 7 gives me 14, and I knew 20 plus 14 equals 37.
So you were doing 2 times 17, and you split that into 2 times 10, or no, 2 times 7 is what you said.
No, I didn't do that. You're doing it exactly right. So 2 times 10, and I said that equals 20.
Okay. So this was split into 7.
Yep.
So you did.
And I did that for first step, and I got 2 times 10 was 20. And then I did the other part of 2 times 7, and I got 14.
Did it this way.
Yep. And then I added 20 plus 4. Kind of, not like that. So the 2 times, yeah. So I did the 2 times 10.
Okay.
I did that separate, and I got 20.
Okay.
And then I knew I still had the 7 ones over there to multiply.
So
I
you
did
did
2
it
times
this
7.
way,
Yes, yes.
You did it this way, distributed the 2.
Yeah.
So 2 times 10 gave you 20, and 2 times
There,
7
yep.
is where you got your 14.
Yep, and then I added it.
Okay, thank you. All right. Keeping that in mind, write this down here so you can see it properly. Okay. What if there were full text examples? Show me your thinking. When you have a solution, if you don't know what it is, if you're not comfortable with all that. Josh, what did you get for the number of 6?
I got 68 6.
68. And Josh? Josh, how did you get 68?
I saw that 4 was twice as many as 2. So I took that and I thought, well, and I can double 2 to get 4. And then I would double, do 2 times 34. I did 30 plus 30 is 60. And then 4 plus 4 is 8.
Sorry, Josh, I'm trying to keep up with you.
Oh, it's all right.
34 times 2. And what did
Yes. And then I did 30 times 2
you?
is 60. And then 4 times 2 is 8. And I added those 2 together.
Okay. So you really split, when you multiplied, you split the 34 into both 30 and 4. You multiplied. How might Josh's example be similar to the strategy that was used for a 2?
You go into easier problems.
So multiplying by 2 is something that we might have access to. Let's move forward. How many 6 are in 20x? 6 might be in 20. Someone's having trouble accessing the problem. That's perfectly exactly where we should be. In just a moment, I'll ask that you turn to the person next to you and use the sentence stem. The process I'm using to solve how many 6 are in 20x is, once again, we're going to turn and talk in just a moment. The sentence stem is the process or strategy that I'm using to find out the number of 6 in 20x is. So this time, please look for my signal. You'll know we're ready to come back together. I'm placed here with my hand up. Please engage in dialogue with another partner around what process or strategy. here, how many sticks are in 20 packs? You can please raise your hand. Who might be willing to share? How many sticks are there?
340.
Can you explain how you might have got 340?
So at first I thought I was going to leave paper out because I thought, okay, I've got 20 packs of gum, so I know I need 20 of those group 17. But then I thought, yeah, I don't want to do that. So I realized that I could go from 2 packs to 20 packs, and that would be 10 times as many packs. And I know multiplying anything by 10, I can just add a 0. I did that.
So you were really flexible in your thinking and making sure that you had multiple strategies to access the problem. It sounds, who might be able to summarize what was offered by one of the students? What happened? What was repeated? Who might be able to rephrase? Thank you, Evan.
Similar to what we saw in the last one when we did 34 times 2. We doubled the 2 to get the 4. And in this case, we times the 2 by 10. So we have to do the same thing to the other side. 34 times 10, base 10, just add a 0. We're done.
Okay, so you're saying that 2 times 10 will give us 20. Why can't we do 34 times 10? We can show 34. Just about for just one moment. Given time, there are a few more examples to kind of stay in this space of complexity for a while to help students feel more comfortable and confident. But just pretend there are 2 more up. Actually, I'll just give it to you. We're not going to go through the process here, but it goes from 20 down to 5. Then we have 15 packs. Sorry, your brains are probably racing at this point. Shouldn't do it. But the last example here is to really push students into a space. And if students are comfortable stopping here, and most students aren't able to access this, cut it off. You do not have to do a full problem. If students are comfortable, you might have something like this. How many packs of gum is that? So to wrap up our problem string, if you can please turn to a partner and very concisely, if you might be willing to share how your thinking has changed. So it might sound something like, my thinking changed from the beginning of this problem string to now by blank. My thinking around problem strings changed from the beginning of this problem string to now by blank. So this will be quick. We are going to have Kelli time us for 45 seconds. Please turn to an elbow partner and share roughly 20 seconds each about how your thinking has changed around problem strings. So before we engage in full group conversation, Kelli is going to ask a question or 2 that might stand out to her that could benefit the group as well. So Kelli, what question pops out for you, either from a student's learning experience or from a professional educator's perspective?
So I noticed you said if your students got to the 15 packs of gum and 255 sticks, and if they were not able to access that, then you could cut it off right there. I'm wondering what your learning intention was for this problem string, and if you still would have achieved that or pushed them there, or if you would have settled with, it's okay, I know my students are not ready for that yet.
So the learning intention for this would be something like students need to become more familiar or comfortable with ratio tables. So what that looks like really depends on where your students are at in their understanding. So hypothetically, if I knew my students were able to access these 2 problems, no problem, but this might be difficult, I'm really going to be tuning in on what their fists are telling me about their access. If I see lots of index fingers up, cool, we're able to access it, we're feeling good. We have this, where we have a thumb and index finger, that would tell me you're getting into some murky water here and we might not want to push too far beyond that. So it's really important that we have those hand signals to read the students on where they're at in accessing the problem. So I don't know if I answered your question.
And it sounds like it's also a valuable tool for formative assessment as you're working through this. I'm wondering, do you make your learning intention visible before
Mm-hmm.
your problem string with
Mhm.
your students?
Mm-hmm. So most often I would have a visual learning intention and success criteria for a problem string itself. For those of you that were at MichME last year, you know that we can have content learning intentions, we can have social learning intentions, we can have practice learning intentions. But I would make that visual and explicit, the purpose of this number talk. I need a swear jar so I can put quarter-inch signs in number talk problem string, excuse me. So yes, I would make it explicit what the purpose of the problem string would be.
How intentional are you with the way that you chart student thinking?
I did my best, and I feel like I did a pretty good job with this. I wonder what you might think about with the models and how it was charted. What did that feel like for you? Other than my sloppy handwriting, I apologize. Mm-hmm.
The modeling how students thought of the addition or the multiplication doesn't really relate to your learning intention.
Mm-hmm.
I guess that makes sense.
Mm-hmm.
If your learning intention is more on the ratios in the table, the time spent explaining how to do 17 plus 17 or 34 times 2 doesn't relate to the intention. So what was your thinking there, I guess?
Yeah, I wanted to make it clear what students were offering to the group. And so you can navigate that differently. So for example, if I just wrote 17 plus 17 equals 34, that's visual of what students said, and we could access it that way, but it doesn't really unpack the computation piece. So that's where it's part of your dance. What is my purpose for doing this? Is my purpose to connect computation to the ratio table, or do I not really care about computation? If I don't care about computation, 17 plus 17 is 34. Leave it. I wanted to offer this as a possibility so we can marry the computation to the ratio table. So there are times you won't do that.
So it sounds like a difference between number talks and problem strings is that you don't always have to spend the time charting thinking the way you did on the right if it doesn't reflect your goal.
Mm-hmm.
Whereas in number talks, you want to value all ideas and really chart that out.
Mm-hmm. And thank you for that question too, because if I don't care about the computation as much, I still need to allow the rest of the group to access the understanding. So it is important how we write it up there as well to allow students access into whoever answered question number 1. I think it was Kelly. Yeah.
I noticed, and this is going to be a difference, I guess, that you collected the answer and the evidence in the same step,
Mm-hmm.
whereas in a number talk, I'm going to collect all the answers and then some evidence. So you jumped right into it, you didn't get time to talk. Is that just to keep the speed going to get to the final thing, cut those steps out?
Mm-hmm.
Okay.
Yeah, the first 1, 2 should be quick. Students access, we're getting the routine, we're getting the flow, gaining momentum. And then later is where we want those strategies to be carried in. And we really did need a turn-in talk at that point with not being able to access the problem. So I would just be mindful of how you're employing those turn-in talks or those other scaffolding activities for students to gain access to the problem. First one should be quick. Yes?
How would you address a student that continues to show you that thumbs up that they're not ready to respond, or just simply doesn't have any visual with their hand signals?
Mm-hmm.
Even if you're trying to adjust to make an entry point available to them.
Mm-hmm. So the question is, if a student keeps doing this and they're not comfortable sharing, I would just wonder why. So I wouldn't call them out, I wouldn't put pressure on them publicly, but I would go to them afterwards and say, hey, I know that you're able to access this information. Can you share a little bit about why you're not comfortable sharing with the whole group? There are a number of other things like, we agree to talk this way in class with each other. We want to make sure you're comfortable having your voice involved because you bring a lot to the conversation. What might I be able to do to help you include your voice? So in a safe way, asking them why, what's going on. Haven't heard from you. Mm-hmm. And maybe we'll take one more question after yours.
How do you handle it when someone gives a wrong answer?
Mm-hmm. Kelly, do you want me to take that or do you want to take that?
How would you have handled it in that situation?
In that situation, I would go through and I would describe it and I would put it up there. And then I would say, How does that relate to the previous example? What connections are you making? And then hopefully by giving it back to the group, someone would say, I don't know if that's right. So once an idea is offered, it's the community's to solve. It's not that student's anymore. So I would record it and capture it and then say, what do we think about that? You wanted to add?
Yeah, it's another question. It was one I was thinking about, because when you wrote the distributive property up there, it's written incorrectly, and that bothered me. But I didn't know the protocol for student feedback. Is it okay for students to question and provide feedback when another student, there's the teacher's job to script out and make sure that that is okay and throw it back to the group?
Yeah, I would offer that that's a dance and in the moment decision on how you want to navigate that too. More often, I should have paused and said, are we okay with this? Are we comfortable with this first? The reason it was handled that way is I just want to put something up there as another option to consider moving forward. But my purpose was to just share as many strategies and models and ways as possible, knowing that we're just trying to have surface understanding of this right now.
To add on to that, we are a new community of learners here. We're just getting to know each other today. In your own classrooms, you have your own community of learners. Stink eye. You have your own community of learners, and you've built up that math community. You might have signals that says, yes, I agree or disagree that are going on at the same time that you can release. You might, you know your students a little bit better than we know you at this point, and to get to your thinking. So I like the way Marcus describes it as a dance. It's kind of a dance between what you have built in your community of learners and how you can kind of go about that, in a way where you're still the facilitator and not the holder of the knowledge.
So Kelly just said stink eye because Rusty opened the door and looked at us and said, oh, you guys haven't started the last portion of the day yet. So we are going to move forward from there. Know that Kelly and I will be around after 3 o'clock as well if you have further questions. But as I mentioned to one group already, the expectation is not that we're masters after an hour and a half of learning. This is our surface learning of where we currently are. So do we want to do that?
Can we do this quickly? This is a useful tool, something I do use in the classroom with my students, but also useful as Marcus and I plan the next session and sessions. If you could, again, quantify your thinking. If I was a 1, where am I at now in my current understanding of what problem strings are? Please use the green star. The green star, come up and place your, I keep wanting to call it a dot, and it's not a dot. Come up and place your star wherever you feel you are at this point in time in our journey.
So thank you for taking the time to learn about problem strings with us today. There are a few closing items and structures that we'd like to share with you. As Rusty mentioned this morning, we are going to be using Google Classroom as our digital community as well. So this is a place for us to pose a problem string that we may have tried, wondering, or a learning that happened. This is really just our space to continue communication in between the MichME days, the Math Network days themselves. So if we could quickly go to classroom.google.com, and the classroom code is presented on the screen. In order to enter the classroom code, there's a plus sign on the top right of the screen. Kelly and I will float around and make sure that we have access to Google Classroom. So as Rusty mentioned this morning, the choice is yours whether you try a problem string back in your classroom. You don't have to. I wonder what we can carry back from our learning today back to the classroom. Whether it's the conversation around our why, or our identity and beliefs, or if we have more tangible examples where I now have the capacity or the skill to at least try something in my classroom. The implementation guide is a place for us to explore what that might be. But we're not going to worry about writing things in there or opening it or creating further understanding at this point. Okay? We're safe right where we are.
In Google Classroom, I will say that I can post a few problem strings that are geared towards K-5. If you really want to get back and try one out and see how it feels, I look for those in the Google Classrooms. You should get an email about it too once we post it there. So.
And I'll post them from the secondary level as well. So this slide, to be clear, didn't make sense to me for like the first 2 years that I saw it. Essentially what this means is you are the district math lead team. So you are here for a reason, And your reason is to communicate what's going on at the Math Network with your building team. Okay? So how are you growing as an individual, but also as a leader in sharing this information? So I encourage you to reach out to colleagues in your building and say, hey, there were some cool things that I learned today. I'd like to share those with you. The building team, the building math team, might be able to communicate with the grade level team too. So this is more of an internal conversation of what are you as members of Math Network doing to communicate within your systems. You'll notice that the MichME lead team is Rusty, Andrew, and myself. Kelli, of course, has a full-time job at Byron Center, but she's glad to work with us too. We're going to think of some ways to continue to build our meetings, our community in between the meetings. So know that we are here as supports for you through this process. If I can just go outside for a moment and say, if you're interested in us trying one in your classroom, I would love to come into your classroom, whether it's kindergarten or 11th or 12th grade. And it would be really cool if we could get a video and then just show it to the group and saying we tried something, with the expectation that I'll do it once, but we might also ask you to do something too. Okay? Okay? So I'm willing to try with your class, so please send me a message directly or Google Classroom. Okay?
I would love to, but I don't think my district will take
You might not allow that. Yes.
I think we have the same question.
Yep.
We don't hit turn in until like the very end.
Don't ever hit turn in.
Turn in was tricky last year.
Yeah,
So I just want to clarify.
Yeah. Don't ever turn it
Can you see what we
in.
put in
I
the
can
sheet
see.
and
We
it's
can
not-
see it the whole time.
Okay.
Thank you for asking. So the last thing, and very importantly, is why we were getting the stink eye from Rusty, is we want to make sure we have your feedback. We really value your experiences today. And conversations are fantastic, but I don't know if I can have conversations. We don't know if we can have conversations with all of you. So please access our survey. It's short. What were your thoughts about the day? What went well? What might be improved for you next time? So please access the survey through this link. It is case sensitive. Case sensitive, meaning capital M, capital D. Okay. We ask that if you have a moment to complete that survey now. But if you have to run, we also understand because we are 2 minutes over. Thank you. We appreciate your openness and learning with us today. If you have further questions, come on up and ask Kelli and I, and we'll see what we can construct together. So thank you for coming.